Polling, or polled operation, in computer science, refers to actively sampling the status of an external device by a client program as a synchronous activity. Polling is most often used in terms of input-output, and is also referred to as polled I/O or software-driven I/O. Polling is sometimes used synonymously with busy wait polling. In this situation, when an I/O operation is required, the computer does nothing other than check the status of the I/O device until it is ready, at which point the device is accessed. In other words, the computer waits until the device is ready. Polling also refers to the situation where a device is repeatedly checked for readiness, and if it is not, the computer returns to a different task. Although not as wasteful of CPU cycles as busy waiting, this is generally not as efficient as the alternative to polling, interrupt-driven I/O. In a simple single-purpose system, even busy wait is perfectly appropriate if no action is possible until the I/O access, but more often than not this was traditionally a consequence of simple hardware or non-multitasking operating systems. Polling is often intimately involved with very low-level hardware. For example, polling a parallel printer port to check whether it is ready for another character involves examining as little as one bit of a byte. That bit represents, at the time of reading, whether a single wire in the printer cable is at low or high voltage. The I/O instruction that reads this byte directly transfers the voltage state of 8 real-world wires to the 8 circuits that make up 1 byte of a CPU register. Polling has the disadvantage that if there are too many devices to check, the time required to poll them can exceed the time available to service the I/O device. Polling can be described in following steps. The host repeatedly reads the busy bit of the controller until it becomes clear. When clear, the host writes in the command register and writes a byte into the data out register. The host sets the command ready bit. When the controller senses command ready bit is set, it sets busy bit. The controller reads the command register and since write bit is set, it performs necessary I/O operations on the device. If the read bit is set to 1 instead of write bit, data from device is loaded into data in register, which is further read by the host. The controller clears the command ready bit once everything is over, it clears error bit to show successful operation and reset busy bit. Description: polling is the process where the computer waits for an external device to check for its readiness. The computer does not do anything else than checking the status of the device. Polling is often used with low-level hardware. Example: when a printer connected via a parallel port, the computer waits until the next character has been received by the printer. These processes can be as minute as only reading 1 byte. Polling is the continuous checking by a controlling device or process of other devices, processes, queues, etc. in some defined sequence to see what state they are in and whether they need attention. A polling cycle is the time in which each element is monitored once. The optimal polling cycle will vary according to several factors, including the desired speed of response and the overhead of the polling. In roll call polling, the polling device or process queries each element on a list in a fixed sequence. Because it waits for a response from each element, a timing mechanism is necessary to prevent lockups caused by non-responding elements. Roll call polling can be inefficient if the overhead for the polling messages is high. There are numerous elements to be polled in each polling cycle and only a few elements are active. In hard polling, also referred to as token polling, each element polls the next element in some fixed sequence. This continues until the first element is reached, at which time the polling cycle starts all over again. Polling can be employed in various computing contexts in order to control the execution or transmission sequence of the elements involved. For example, in multitasking operating systems, polling can be used to allocate processor time and other resources to the various competing processes. In networks, polling is used to determine which nodes want to access the network. It is also used by routing protocols to retrieve routing information, as is the case with EGP. An alternative to polling is the use of interrupts, which are signals generated by devices or processes to indicate that they need attention, want to communicate, etc. Although polling can be very simple, in many situations it is more efficient to use interrupts because it can reduce processor usage and/or bandwidth consumption. Poll message: A poll message is a control acknowledgement message. In a multi-drop-line arrangement, the system uses a master-slave polling arrangement whereby the central computer sends message to a specific terminal on the outgoing line. All terminals listen to the outgoing line, but only the terminal that is polled replies by sending any information that it has ready for transmission on the incoming line. In star networks, which, in its simplest form, consists of one central switch, hub, or computer that acts as a conduit to transmit messages, polling is not required to avoid chaos on the lines, but it is often used to allow the master to acquire input in an orderly fashion. These poll messages differ from those of the multi-drop lines case because there are no site addresses needed, and each terminal only receives those polls that are directed to it. See also, poll technology, interrupt request, KQUEUE, multiple asynchronous periodic polling, select, references.